This problem involves using type Boolean. We're asked to write a method called isLeap that takes a parameter n and that returns whether or not that n is a leap year. And we're given the rules of leap years here, that in general rules that are divisible by 4 are leap years, but that adjustment is off about every 100 years, so we have another rule that says that years divisible by 100 are not leap years, and then that rule makes a mistake about once every 400 years, so we have yet another rule that says that years that are divisible by 400 are leap years. If you're wondering, this set of rules is going to keep us okay for about 8,000 years, so we have a little bit of time before we have to think about how to do an adjustment in the other direction. So here are some examples of what we're supposed to do. 1600 and 2000 were leap years, but 1700 was not. 2008 is kind of a standard leap year. 2009, 45 are not leap years. I've set up a JGrasp file that has a little testing method in it. It's just that there was a lot going on in this println statement right here, so it was nice to put it in its own little method, and that way I could easily enumerate a bunch of different test cases that I want to perform. I've included everything from the table, and this will make it very easy for us to take a look at our answers and see if our code is working right. So our task is to write a public static method called isLeap, and it's supposed to have a Boolean return type. So we've been writing methods that return int or double or string. Boolean is another return type that we can use. This one is called isLeap, and it takes an integer n as a parameter. We're supposed to figure out whether n is a leap year or not, and that's a yes-no question, a true-false question. That's why the return type is Boolean. One way to solve this problem is with a nested if-else, where we simply enumerate all the various kinds of cases. So let's explore that first. You might think that we'd begin by saying if n mod 4 is 0, but that's actually not going to be the best case to start with. For example, 1600 is divisible by 4 and it is a leap year. 1700 is divisible by 4 and it's not a leap year. So we get different answers for different years that are divisible by 4. So in fact we want to start in the other direction. We want the most specific case. So we want to start with the 400 case, because 1600, 2000, 2400, 2800, every single one of those years is a leap year. So we would return true for each of those. It may seem odd to say return true, but that's what we do with type Boolean. We have two values, true and false, so if you want to return the value true, you can simply say return true. Otherwise, our next most specific rule says when n mod 100 is 0, when it's divisible by 100, so those are century years like 1700, 1800, 1900, 2100, because we already dealt with the 400 years, and all of those other century years are not leap years, so we can return false for them. And otherwise, we'd be ready for our more general rule about years that are divisible by 4. And in those other cases, years that are divisible by 4 would be leap years. So we can return true in those cases. You might think that you're done, but in fact these were our special cases, years divisible by 4 and by 100 and by 400, but there are a lot of other years like 2009, 45, so we have to have a case for them as well. So we can say in all of those other cases, those are not leap years. So we can simply return false for all of those other years. So this is one way to solve the problem with a nested if-else that just deals with the different cases and enumerates specifically whether you want to return true or false in those different cases. We can compile it to make sure we did that right and run it and see what answers we're getting. And we'll see that it's saying that 1600 is a leap year, 1700 is not, 2000 is, 2008 is, 2009 is not, 45 is not. Or if we compare it against our table, the table goes true, false, true, true, false, false, and our answers go true, false, true, true, false, false. Same pattern in our answers here, so that's good. So this would be one way to solve the problem, but it's kind of a wordy solution to it. And if you really understand how to use type Boolean well, you can do much better. So let's make a copy of this so that we don't forget our solution. And I'll paste in the original here. So what I'm going to do is I'm going to make a multi-line comment out of the old version of the code. That way we'll be able to look at it later on. But then we have a live bit of code here that we can manipulate. So the simplest bit of this to pick off is this final little test that we're doing that involves n mod 4 being 0. So let me do the following. I'm going to actually put a couple of blank lines in here and have a set of curly braces here. So what we had in this else branch was this if else. So this is what we were doing inside of this else branch. So whatever we do here has to be equivalent to this if else. And this if else worked, but it was a little bit wordy. So remember the way the if else works. It has a test that Java is asked to evaluate. So we ask whether n mod 4 is 0. That's something that evaluates to either true or false. But since it evaluates to a Boolean result, we can do something better than what we're doing here. Take a look. We're saying if this test evaluates to true, return true. And otherwise, well, in the case of Boolean, the only other possibility is that it evaluates to false. So else, if it evaluates to false, return false. So if it evaluates to true, return true. If it evaluates to false, return false. But then why not just say to return the answer we get when we evaluate whether n mod 4 is equal to 0? We can just directly return the result of evaluating that expression. That way, if this expression evaluates to true, we're returning true. If this expression evaluates to false, we're returning false. This is something that we referred to in the book as Boolean Zen. So this expression right here, this one line of code, is equivalent to this longer, wordier if-else that we have right here. And in general, it's good to learn how to use the idioms that are standard for a type like this, the Boolean type. You want to be able to use the type effectively, and you want to be able to read other people's code. So when we can say something in a more concise way, in general, we want to do that. So this simple one-line return replaces the old if-else that we had right here. And we can compile again and run just to make sure that we haven't screwed anything up. And if we take a look at the answers that we're getting, we'll see that we have true, false, true, true, false, false. So we're getting the same answers that we got before, which is good. So even this that we've done so far is a nice little improvement on the if-else that we had before. But we can do even better than this. So let's take this line of code right here, and let's make a copy of it. And then let's paste in that copy of it and fix the indentation. So the idea is, can we have a single one-line return here that would take the place of the entire nested if-else that we had before? The answer is going to turn out to be yes, if we understand type Boolean well enough. So why isn't this the right answer? This one says return true when n mod 4 is 0. Well, it returns the right answer in a lot of cases, but it returns the wrong answer for 1700. 1700 it's supposed to return false, and it would end up returning true because 1700 is divisible by 4, but the answer is supposed to be false. That's because the simple expression that we have right there is not taking into account the century rule, the n mod 100 being 0 rule. That in general those centuries are not leap years. So it's not enough to know that something is divisible by 4. There's something else that has to be true for us to be able to say that it's a leap year. This is a nice place to use what's known as the Boolean AND operator. So we can have an extra constraint that we want to place on this. We can say that n has to be divisible by 4, and it has to be the case that it's not a century year, that it's not divisible by 100. So we can say, and not the case that n mod 100 is equal to 0. So there's an operator called not, and we could do it in this way. We could basically say, I want to make sure that this test evaluates to true, and that it's not the case that this test evaluates to true. So this would certainly be a reasonable way of writing that, although most people wouldn't actually use the not operator here. They would tend to just change the operator inside of the parentheses and say that the two things I want to have be true are that it's divisible by 4 and that it's not divisible by 100. So this now classifies all the years divisible by 4 as leap years, but still says that the century years are not. So 1700 is not, 1800 is not, 1900 is not. But again, this goes too far. Now 1600 is not a leap year. 2000 is not a leap year because this century rule is cutting those off as well. So we do need to incorporate this 400-year rule somehow into the expression that we have here. Well, this expression is working pretty well for almost all of the years that we have. The only years that it's getting a wrong answer for are the ones divisible by 400, 1600, 2000, 2400, and so forth. So for those years, it's enough to know that it's divisible by 400. That information alone tells you that you want to consider it to be a leap year. So this is another place to use a Boolean operator. Here we'd want to use the Boolean or operator, because we don't want to say that both of these things have to be true. What we'd say is it would be enough to know that n mod 400 is 0. That this information alone, just knowing that this test evaluates to true, that is enough to know that the overall answer is true. But if that's not the case, the OR operator says that then we'd look at all this other stuff. We'd see whether that other rule we just developed would evaluate to true. And in all of the other cases, it evaluates to false. So we should be careful here and introduce some parentheses to make it very clear what's going on. So we could include some parens here to make it very clear that we're grouping this set of stuff together. We're saying if this evaluates to true, or if this little test over here evaluates to true. It turns out actually that these parentheses aren't necessary because the AND has a higher level of precedence than the OR, but a lot of people like to include them just to be very clear about how that expression is grouped. So what I'm claiming is that this new expression, this new one-line expression, allows us to completely eliminate the old if-else. We can verify that by compiling the code and running it, and just make sure that we're getting the same answer as before, and we're seeing the true, false, true, true, false, false, same pattern that we got before. We might want to do some more testing just to be absolutely sure, but it turns out that both of these are solutions to this problem. One of them is a little more tedious, using a nested if-else structure and just explicitly returning true or false. The other one a little more concise because it uses a better understanding of how type Boolean works, using Boolean operators to form a single expression so that we can write it as a one-line method. So both of these are solutions to the problem that we were asked to solve.